this is our lesson on the regression line. This is the beginning of lesson 43, and this is the first lesson where I'm going to try to reformat how we do the virtual learning so that maybe it's a little bit easier for you to manage. So you should be seeing this video in a quiz. So this, I'm not sure if it'll show up in like the instructions to the quiz or if it'll show up in your problems. I'm pretty sure it'll be in the instructions box for your quiz, and then underneath it will be a few questions. So I'm going to do part of our lesson and then ask you a couple of questions that have to do with this part of the lesson, and then the next one will be part 2 with a couple of questions, and then the next one will be part 3 with a couple of questions. So by the time you're done with lesson 43, you should have completed 3 quizzes. Now, they're not really going to count as quizzes on your grade. I think maybe I'll put them in the place of your can you do's. So I think that that'll be the plan, but we can figure that all out later. So, okay, let me make myself small. And then, so like I mentioned, this lesson on the regression line has 3 parts. So there's the part where we use your calculator to actually find a regression line. Then there's a part where we interpret the regression line, and then the last thing that we do is talk about this idea of extrapolation and what values we can use our regression line on. So how do we find it using our calculator? How do we interpret it? And what values can we use it for? So this whole idea of a regression line is based around the same idea as a line in mathematics. So in 9th grade, you started learning about lines and that lines can be written using an equation. So let's say we have the line y equals 2x minus 1. So hopefully this doesn't sound too foreign. This is your x-axis, this is your y. I'll draw in some tick marks just to help out a little bit. I'm not being very careful because I don't want this to take forever. And this was slope, and this was y-intercept. So how you would graph this line is that you would start at -1, because that's where it's at on the y-axis, and then your slope is that every time you go over 1, you go up 2. So this is rise over run. So we would go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then it starts to, you can start to see what the straight line is going to look like. So this is relying on our background knowledge of a line and how a line works in terms of y-intercept and standard deviation. So fast forward to AP Stats, and now what we're talking about is the relationship between 2 quantitative variables. And several times in our notes, we have talked about whether or not the scatter plot has a linear relationship. And I talked about how, well, you could put the line in yourself. Like, if you're wondering about how strong the line is, then you draw a line that you think fits the data and see how close to that line it is. So like I could draw in a line that I think fits here. I could draw in a line that I think fits here. So the regression line that we are talking about today is this actual line. This line that we're drawing through that we think describes this relationship. We're going to formalize that today and actually find a line in terms of y-intercept and slope. So that's where we begin on this note sheet. So we use a regression line to estimate. We use a regression line to estimate. And we should probably also add in the word predict here, to estimate or predict the value of y for a given x. I can't tell if it's just my cheap glasses that are making this look blurry or if it's blurry. I think that might be a little bit better. Okay, so the investigation of this line is all based around this data set. Cars and trucks lose value the more they are driven. A random sample of 16 used Ford F-150 Super Crew 4x4s was selected from those listed for sale at autotrader.com. Okay, now I'm going to tell you a story that has nothing to do with stats, so fast forward if you want to. So when I was a kid, probably a little bit younger than your age, so maybe junior high, like 7th to 9th grade. You guys got to remember that back at this time, there are no cell phones. Like, there are cell phones, but they're the size of a brick, and very few people have them. My dad used to be a car collector. He was really big into old muscle cars, and he would love to go through the Auto Traders every week. But we didn't have internet at this time, so Auto Traders were literally magazines that you went through, like magazines with 100 pages, and it was all of the cars for sale in your area. And I remember as a kid, we would have like 20 or 30 or 40 of these Auto Traders laying around. Like, I remember my dad saying to me, hey, go to the gas station and get me an Auto Trader. So every time I do this example, it reminds me of him, because now there are no Auto Trader magazines. Now you have to find everything online for stuff like this. So anyways, that's just a little side note. Okay, back to business. So we get the data here, and we can use our calculator to generate the line that matches this line in our data. So maybe I should rewind a little bit. Focus on just the red dots for now. We see a strong, maybe it's moderately strong. I think maybe it's on the borderline of strong and moderate. We see a strong negative linear association. So we're going to use our calculator to find the equation for the line that best describes the relationship. So we get into a little more depth how we find the line that best fits the data. But essentially what we're doing is we're trying to figure out which line matches this the best. So for instance, if I put in a line like this, it is a negative association, but it does not fit the line as good as this blue, or sorry, does not fit the scatter plot as good as this blue line does. So you can see on this line that has been generated that there's about the same number of points above the line as there is below the line. So your calculator, we can use your calculator to figure out what the equation of this line that best fits is. I guess we should add in as well that the regression line is also referred to as the line of best fit. The line of best fit. Okay, so step number 1 is that we have to get this data entered into our calculator. So right now I have a ton of data sets going on. So I'm going to spend a second to see if I have this in one of my calculators. And you should be rounding up your calculator and entering in this data for yourself. I'm pretty sure that I don't have it entered. So let's both pause We'll both pause. I'll pause the video. You pause the video. Let's enter in this data. It doesn't matter into what lists, and then let's meet back up once we have it. Okay, I think I have mine entered correctly. You just want to verify at the end that you have these written in, sorry, not written in, you want to have the same, I don't even know what was happening there. You have the same, these end at the same spot, so you have the same number of observations in each list. Now, one thing that I like to do, because obviously my brain sometimes does weird things, is I like to write down where I put the data at. So I put miles driven in list 3 and price in list 4. And I didn't do a really good job leading into this of describing what this data set is. So what we're looking at is, can we use the miles driven to predict or explain the price of a car? So the idea is that the more you drive a car, the less it's worth, because cars have a lifetime. Like, people typically think about a car's lifetime in terms of miles. So you would think that as you drive more miles, your car costs less because it's not going to last as long the more miles you drive. So we're seeing that in the scatter plot. We're seeing that as the number of miles you drive increases, the price that you can get for your car, or the cost of the car, decreases. That also has to do with time. Like, it takes time to put miles on your car, so the more miles you have, the older the car typically is as well. So now we're going to use our calculator to find this regression line. So the buttons are stat, and we're going to fill these in just a second, fill in the buttons, stat, arrow over to calc, hit option 8, fix your list. So remember, you have to hit blue button, the number that your list is in. It's a good thing I wrote mine down because I didn't remember. So my X list was L3, my Y list was L4. Enter, enter, enter. And now, hopefully as we was pressing these buttons, you guys realized that this is something that we have seen before. We use this to find R. So we can see that this truly is on the edge of moderate and strong. Our correlation is negative 0.81. And these values that have been up above R each time we've calculated it build your regression line, or your line of best fit. So in this box, I have pulled this same data so that we don't have to keep going into our calculator. If yours doesn't match mine and the worksheet, you probably just entered in one of the values wrong. So to get here, we hit stat, we arrowed over to calc, and we chose option 8, which is your linear regression. So hopefully now that makes a little bit of sense why option 8 is labeled as linear regression, because it helps us find the regression line. Okay, so now you can see the form of our line. It doesn't exactly match the form of the line that I drew at the beginning of this lesson, because previously we knew the equation for a line to be y equals mx plus b, and m was slope, b was y-intercept. In stats, you do that slightly differently. So in statistics, A is your y-intercept. A is your y-intercept. And B is your slope. Now, notice that slope is still attached to the x value. It's just rearranged, and we use different letters. And if you ever forget it's written right, your calculator reminds you every time you run your linear regression. It tells you in the window what the formula is. So now let's see if this looks about right. So at 0, we have a price of about $38,000. So that looks right. And then our slope is that we go down by 0.6 every time we increase by 1. So what this is telling us is, and we'll get to this, the details of this in the next lesson, but what our regression line is telling us is that for every mile we drive, we lose 16 cents off the value of our car. So this is, in this case, it's money. This is $38,000. This is $0.16, which is 16 cents. So every time we drive a mile, on average, our truck decreases in value by 16 cents. We have two options for writing our line of regression. I forgot to tell you one important thing. This is not the important thing. It is 6 p.m. at school, and I am, like, my brain is fried. So this is not the best quality lesson, and I apologize for that. This is very special. This Y hat, you say it Y hat because he's like a Y with a hat. This is predicted Y. It's really important that you know that that hat is predicted Y. Okay, so two options for writing the regression line. The first one is using words to describe the variables. So our Y is price, and we would need to put a hat over that because that means predicted price. Equals, okay, well, our A value, our y-intercept, is 38,257. And I'm not going to write 0.14 because this number is already really long. So I don't want to make it 7 digits long to put 14 cents on there. If you guys do, there's no issue with that whatsoever. You are absolutely allowed to say 38,257.14. Our slope is negative, so we're going to say minus. Instead of having a plus sign here, we're going to say minus. 0.16, so I rounded that so that it looked like money. And then in parentheses, we write what the x variable is, and that is miles driven. So option 1 is, what is option 1? Family? Use words. Option 1 is that you use words to write your line of best fit. Now, most frequently, we use the next option. And that is to use variables, y hat and x, and then explicitly state what those variables are. So in this case, we say y hat is, or y hat equals 38,257 minus 0.16x. And just as a reminder, this minus is because the slope was negative and the relationship is negative. If it would have been positive, we would have put a plus sign there. And now we have to say where x is miles driven and y hat is predicted price. So option 1 is using words. Option 2 is using mathematical symbols, but then clearly defining your variables. The preferred option is the bottom one. The preferred way of writing it is the bottom one. You'll see both because both are acceptable, but I would get really comfortable with writing it this bottom way and knowing that this part here where you explicitly define the variables is very important. Okay, so that is part one. Now what you are tasked with is answering 3 questions below. So what I have given you is 3 tables, and for all 3 tables you have to enter the data into your calculator and find the line of regression. There's different ways to enter it. I will allow you to see the correct answer. And then remember, if you get like a 20 on this quiz, it's not going to translate over to your grade as a 20 out of 50. I wonder if I should just take the point values off altogether and just make it worth 0 points, but I would still be able to see whether you do it. So it might not be worth 50 by the time that you do it. I'll decide that while this video is uploading. Okay, so that's part 1. We're done with part 1. How do we find the regression line? You do your short little quiz to practice what you just learned, and then you'll come back and we'll do part 2, which is interpreting your regression line.